Hey folks, today we're going to talk about reaction types. There are 5 different types of reactions that you need to be familiar with, and you might want to write these down, but leave some space where you can just wait. We're going to be going through all 5 of these in just a moment on different slides. Alright, direct combination or synthesis is exactly what the name implies. It is combining 2 or more reactants coming together to form a single product. So, if you think of 2 elements coming together, the important thing is that they form a single product on the right. So here's an example of some elements, hydrogen and oxygen, coming together to form water. So that's an example. Notice there's a single product. We also could have carbon dioxide and water coming together to form carbonic acid. But the key thing here, folks, is that you've only got one product on the right-hand side. That's what's important. That's how you recognize a direct combination or a synthesis reaction. Now you could, I want to talk about this one right here, which to me is a very important reaction, hydrogen plus oxygen giving you water. You've probably seen a picture of or watched a video of a space shuttle taking off. Now these big white things on the left-hand side, these are solid rocket boosters, and out here they put a bunch of smoke. You've got one on each side, right, putting out all this smoke. So why are we talking about this right now? Because the stuff that's in there is ammonium perchlorate and aluminum and some other stuff that's all reacting together. That's not a synthesis reaction. But this is. Up here inside our fuel tank, we actually have hydrogen gas, or actually hydrogen, it's liquid hydrogen because it's so cold, hydrogen and oxygen both in this tank up here, and they get pumped through the space shuttle, and coming out the back, they actually combine, and when they combine, they make water. So the stuff that's actually coming out of here is water. It's actually steam. It's very, very hot water, but it's superheated steam, and it is generating thrust that's pushing the space shuttle up into orbit. Okay, so just kind of an example of how we use a direct combination reaction. Now, decomposition is exactly the reverse of direct combination. So if I look down here, I can see that one thing is becoming 2. So let's specifically look at our example with water, where water can be broken up into hydrogen and oxygen. We do this using electrolysis or electricity, where we put electricity into water and we get some bubbles of hydrogen coming off one side and some bubbles of oxygen coming off the other. So decomposition, how do you recognize it? Only one reactant. The only thing it can do, if there's only one thing over there, is break apart. And that's exactly what decomposition is. So decomposition and synthesis are exact opposites of each other. Now, why do I have a picture of somebody going to prom here? Well, the concept of a single replacement reaction is there's another person who comes to the dance all alone, right? And this young lady over here says, you know, this new guy, he's cuter than the one I'm with. So she dumps this guy, sorry buddy, and she comes over here with this new guy over here. That's called a single replacement reaction. We have one person coming to the dance alone, and over here we have a couple. And when they leave the dance, the couple has now separated into 2, and one of the members of the couple has come over here with the person who was alone. So let's look at that in chemistry. An uncombined element displaces an element that's part of a compound. So here we have an element that's A, and here we have our couple over here who is BX. And what happens is A and B switch places. For whatever reason, and we're going to talk about that in our next podcast, A and B switch places. So A bonds with X, and now B is all alone. So how do you recognize a single replacement reaction? Well, the reactants are always an element and a compound. And the products, similarly, are going to be a compound and an element. So let's look at this reaction right here. For example, we have iron and we have copper sulfate. And iron is a metal and copper is a metal, and the 2 metals switch places. So the copper is now all alone on the other side, and the iron has bonded with the sulfate. So that is a single replacement reaction. The way you recognize it: element, compound, producing a compound and an element. And the compounds are different. Alright, so let's go to another dance. Let's say that the two girls at the dance decide they're going to switch guys. So this guy over here goes over here, and they swap. They swap partners. Well, their outfits wouldn't go very well together if they swapped partners, but that's the way it is. That's the concept of a double replacement reaction. You have two couples, and they swap partners. So what does that look like in chemistry? Well, atoms or ions from two different compounds replace each other. So let's look. We have A and X and B and Y. Think of these as two ionic compounds, where we have two metals and two nonmetals, and A and B are going to switch partners. So B is going to go with X, A is going to go with Y, and you end up with two compounds on the right. So you have two compounds as reactants, you have two compounds as products. Let's look at an example. Here we have calcium and hydrogen. Calcium is bonded to carbonate, and hydrogen is bonded to chlorine, but they're going to swap partners. The calcium is going to come and bond with the chlorine, and the hydrogen is going to come back here and bond with carbonate. So the way you recognize this is you have two compounds as products, you have two compounds as reactants, and you'll notice that you can essentially draw a line through them and say the two metals, or more precisely the two cations, swap. Okay? That's the way you should recognize a double replacement reaction. And finally, our fifth reaction to look at is a combustion reaction. Now, generally, the reactions are between a hydrocarbon and oxygen. Now, the hydrocarbon could be just with carbon and hydrogen in it, or it could be what we call a CHO compound, or having carbon, hydrogen, and oxygen, all three in it. What's key here is we form carbon dioxide and water. So if we look on the right-hand side, if we look at our products over here, they're both carbon dioxide and water. Now, on the left, we have something called ethane, and ethane is mixed with oxygen to produce carbon dioxide and water. You'll notice that ethane is simply a carbon-hydrogen compound. Or we could have ethanol, which is ethyl, also known as ethyl alcohol, and it's combined with oxygen. It still produces carbon dioxide and water, but you'll notice there is an oxygen in this compound as well. Okay? So combustion is, as the word implies, something burning. So it conceivably could be a piece of wood burning. But anyway, the reaction is between a hydrocarbon, a CH compound, or a CHO compound, and it's always forming carbon dioxide and water. Now, I'm not going to spend a lot of time giving you a bunch of other kinds of reactions. These are the 5 main kinds of reactions. So if you see a reaction that isn't one of these, then just accept it's not one of these. Okay? And just label it as something called other. So if we look at this first one, you might think, because it sure looks like it would be a double replacement reaction, because the silver would swap with the potassium, and the potassium would go with sulfur, and in fact the potassium does go with sulfur. But look over here at the silver compound. There's still potassium with it, and that looks kind of goofy. Right? So this is definitely not one of the 5 reaction types that we've seen, nor the other 2. I'm not going to spend a lot of time on that, but just so that you know, there are many types of reactions that do not fall into those 5 categories. Now, there is a YouTube link if you look at your, if you look online, or you look at your, your packet, right, you're going to find there's a YouTube link out there that gives you some examples that you can actually see of all 5 reaction types that we have. But let me just give you a couple of examples just so that you can say, what are they? All right. Na plus Cl gives you NaCl. What kind of reaction type is that? Clearly, that's direct combination or synthesis. You should be able to pick that up pretty quickly. How about MgCl2, and it's going to become Mg and Cl2. Well, clearly that is the reverse of synthesis. This is something called decomposition, where something's breaking apart, one thing is breaking apart into two pieces. And what do you see here? Sure, that's a single replacement. How do you know it's single replacement? Well, I have an element, and I have a compound, and it's producing a compound and an element. Now, guys, I realize these aren't balanced. I'm not worried about that at this point. I just want you to be able to recognize the reaction type. Alright, so we have barium nitrate and nickel sulfate, and we're going to produce barium sulfate plus nickel nitrate. And the question is, what type of reaction is it? Well, you should be able to tell that the barium and the nickel are swapping partners. So the barium is going to be with the sulfate, and the nickel comes back to be with the nitrate, and that is a double replacement reaction. Okay, this is sugar plus oxygen, and it produces CO2 and water. So what is that one? Yep, that's going to be a combustion reaction, very common combustion reaction, because you're producing carbon dioxide and water, and you have a CH or a CHO compound on the left, and you're combining it with oxygen. All right, folks, it's your turn. Go off and do the worksheet. If you have questions, please come see us in class. We'll be happy to help you in any way we can. Have a great day. We'll see you later. Bye-bye.